The equation of a straight line L is this. O is the origin. Find the position vector of the point P on L such that OP is perpendicular to L. A point Q on L is such that the length of OQ is 3 units. Find the two possible position vectors of Q. So here's our straight line L. Suppose it's like this. This is the line L. And suppose our origin is here. Then what it's saying is find the position vector P on L such that OP, so O to P then, is perpendicular. Apologies for the digital pen drawing. So this would be P then, wouldn't it? And OP now would be perpendicular to PL. So P lies on L, as it says. So part 1 then, let's have a look at this. So OP, we'll let P be the position vector X, Y, Z. Here. So the dot product X, Y, Z then, that vector is perpendicular to this directional vector. So that dot product equals 0. So X minus Y, 0 Z equals 0, X equals Y. The other thing to say is that P is on the line L, so here 1 plus T. So 1 plus T, X equals Y on at the point P, doesn't it? So the X coordinate, 1 plus T, must equal the Y coordinate, 0 minus T. So that implies, no, we can write also because it's an additional piece of information. So that tells us what T is, doesn't it, when we use X equals Y, and the P coordinate is of this form, 1 plus T, minus T, and 0. So we could put that in here as 1 plus T, the coordinates of P, 0 minus T, and 2 plus 0. So when does X equal Y? Is when this happens. Bring the 2t over there then, equals, and move the 1 over. So that tells us t is minus a half. So we can find out p. So p has coordinates then. OP is the vector x, the 1 plus t rather, the x value. T is minus half, so that will be a half. The y equals x, so the next value minus t will be a half, and then the z value is 2. So find the position vector, which we've done. A point Q on L then is such that the length of OQ, so here's Q, say, and it could be here, say, as well, put a dashed. So OQ, and that possibility, this distance, OQ, or this distance here, is 3 units. So what does that give? Find the two possible positions of Q. So OQ lies on L, so we can square both sides here. This modulus squared. So here's the parametric representation of a point on L here, I think. Yes, there it is there. 1 plus 2t minus t and 2. So Q will, this squared then. So square it, so use Pythag, 1 plus t squared plus minus t squared is a t squared plus the 2 squared is 4 is equal to, and then that would be 3 squared is 9. So this is a t squared here and a t squared. So we end up with 2t squared. There's 2 t's inside the bracket when we expand it, plus the 1 plus the 4. Is 5, minus 9 is minus 4. Divide by 2, all the way through, and that tells us the values of t. So we should be able to factorize, hopefully. 2 1s, plus and a minus. That gives us t squared. 2 take 1t is plus 1t. Minus times plus is a minus, 2 1s are 2. So t is equal to 1, and t equals -2. So Q. Now, did we need to find the coordinates of Q? Find the two possible positions of Q. So the positions as a coordinate. When t is 1, what do we get? We get 2 minus 1, 2. 2 minus 1, 2. Or we'll call it Q dashed. Now put -2 in. -2 in here. -1 plus 2 plus 2. -1 plus 2 plus 2. And there's our two possible positions of Q.